All right, we are live.
Hey everyone.
Hi, everyone. Good to see you. Thanks for joining today. Good to hear where everyone is joining in from. Feel free to add that to the chat. It'd be great to see which locations have dialed in. Here we have Switzerland. Cool. All right, let's get going. So yeah, hi everyone again. My name is Artur. I do product marketing at Mistral AI. Welcome to our webinar on OCR and Document AI, our solution for digitizing documentation and transforming your document life cycles. Really cool to have you all join. I think more people will join as we go in the next couple of minutes. I am also joined today by my colleague Geoffrey Thomas. He's based in Paris. He's from our DevRel team.
Hi everyone. Yeah, pretty much everything has been said by Arthur. Nice to meet you.
Here we go. All right, we have Germany, New York, Netherlands, Munich, France, of course, Austin, Texas, Quebec. Fantastic. All over the world. Brazil, Bhutan, Colombia. Awesome. Across the continents today. So cool. Let's get going. You probably have a good idea of what our webinar topic will be about today. So I will introduce it, just recap what we're actually going to run through in this first webinar. May well be first of a series. This one we are dedicating to our solution on document AI, document intelligence, and OCR. Some of you will probably have already tested our OCR model in the past. It's recently undergone an update, and we're keen to share with you the latest on what it is, how it works, how it can benefit your business. So when we started building our OCR model, we understood that organizations and businesses, public sector entities, they're dealing with millions of documents, thousands of documents per day, and entire pipelines of documents coming in and that need to be digitized, archived, and so on. They're often scanned, handwritten, multilingual, and the reality is extracting data from those documents is really hard. And there have been OCR solutions in the past or older solutions which have done the trick to an extent, but those systems have a tendency to be quite slow, expensive, or rigid, and just not great at interpreting the complexity of layouts that you can get with some of these documents. I'm sure some of these examples might look familiar to you. So there are common documents with odd layouts, let's put it that way, with not easily discernible columns, images contained within. There might be alternating row colors, and also handwriting is especially relevant for certain industries like healthcare. Um, Text within images, and of course, the issue of some scans or many scans are actually of poor quality. So all of that needs to be digitized and ingested into your organization's database for, for further use. So we first built our OCR model and have since improved it, and then have overall packaged it into what we call the Document AI solution, which is actually much more than just basic OCR. And we'll explain more, and also Geoffrey will walk you through a live demo of what exactly we mean here. So we are very confident that Document AI and our OCR model can boast to be the most accurate OCR in the world, and also offer extremely versatile annotations, document understanding, and all the way through to complex workflows that you can set up to have then your employees, yourself, be able to reference and look up, query the newly ingested data from those scanned, digitized documents. Among the biggest benefits that our OCR model and Document AI present is superior accuracy. So we've seen from text extraction, handwriting, tables, and images, the benchmarks show exceptional accuracy compared to other solutions. And also, it's very good at multilingual documents. So being able to interpret documents in various languages and to a high level, high degree of accuracy. For example, you might need, so bring back that healthcare example, might need to extract handwritten notes from scanned medical forms. Mistral can handle that very well, cleanly, out of the box. The other aspect is fast processing speeds and also predictable costs. So our OCR model is able to process up to 2,000 pages per minute on a single GPU. It's perfect for high throughput pipelines. It's also multimodal. It's very good at a wide range of different file formats, PDFs, Word docs, various scans, low quality images as well, and it outputs into clean JSON, not just raw text. Another interesting example that we've come across as well, so for example, manufacturing firm needs to bulk process shipping documents, scans, custom forms, warehouse checklists, and so on, and it pipes clean data into their ERP and does it at scale. Perhaps most importantly, and this is what I was hinting at earlier, is the end-to-end intelligence aspect. So Document AI paves way for a pretty serious transformation of your document life cycles. So you're able to digitize, extract, classify, as I mentioned earlier, query, all in one model-driven flow. Another good example is you might be a finance company in finance, a bank, be automating a full KYC check. So you'd be needing to scan ID documents, extract fields, cross-check metadata, flag any anomalies, remain compliant in the process, all through API. And then you would need to have, for example, your teams query the now enriched archive. So in a nutshell, this is Document AI and OCR. I think we need to get into the juicy segment now. So I'm going to hand it over to Geoffrey for a live demo, and he will do a live walkthrough and demonstrate what Document AI can present in its capabilities. Geoffrey, over to you.
Hi, everyone. So let's go to the live demo. But first, let's go through a couple of slides more before we dig into the code. So when we reference our Document AI pipeline, what we mean is actually OCR. OCR stands for Optical Character Recognition, and this is the power to reconstruct information from a document or an image as text. So as Arthur mentioned, some of them may be a scan document or just basically PDF or JPEG of those documents. This is really easy to start asking requests to our OCR model. This example is actually using the document like argument, but you can pass in images too. To pass to our API, obviously you need to convert to base64, but pretty easy to start having the text extracted from your document. Let's go through the demo. So if you actually want to make some requests, what our model will give you back, if you encode it, you provide the Mistral client, you encode your document. In this case, it's the Mistral 7B PDF. And if you send it to our client, you will get an answer that looks like that. You will have pages divided by index. So this is the first page, which contains the markdown content of that specific page, along with the image that the model has segmented into this page. And so this is the case for page 1, where you have the content as markdown and the images with the base64 that you can choose to have or not, and so on for the whole document. So in this case, my document has multiple pages. So for all of that, I do have the markdown and the images. On your side, once the text is extracted, you can choose basically if you want to reconstruct it. Here I made some pretty simple Python code. If you look into the Markdown, you will see that there will be some reference to the images and where they should be placed. So for instance, here, the page 4 starts with images5.jpg. And this is where in the document that the image has been extracted from and where it should be replaced. So if those mark and like specific annotation of where your image should be in the document, you replace them with the actual image, you can see that the quality extraction of the model is already pretty good as it is with only the base model. We'll see later that we have more features that you can toggle on and off. But this is like the basic of extracting text from a PDF document. I do have a little bit of a playground to showcase like some of the edge cases that you may encounter. So in traditional documents where they actually like traditionally OCR is not done through a VLM. Here we have a VLM that is fine-tuned to actually give you back the Markdown representation of your documents. And this is what changes everything. We can upload a document. Let's take, for instance, like a scanned document and compare the accuracy from our Mistral OCR model compared to basic text extraction. You take the PDF and you just extract the text that you can. And with a more traditional technique like Tesseract, for instance. If we do the extraction, we can see that we have pretty much the same speed as what traditional OCR technique would have, but the quality here is roughly the same. Let's be real. Tesseract does a good job at extracting the content of the document, while a naive technique of only extracting text here fails because obviously it's a PDF, but the content itself is an image. So we cannot extract any text with only a Python method to extract the text from a PDF. If we take, we will see the limit of traditional technique, for instance, with a paper like Pixel 12b. If we choose to actually send a request, let's say to page 8 of that document, only the text extraction only doesn't have any layout. This is bad, and like a Tesseract solution doesn't have anything for like tables. It cannot like give you back the chart and so on. While like just the naive implementation of Mistral OCR give you back a Markdown table, which is well formatted and contains the exact same information that you have in the original document, as well as your chart that is contained in your original document. But where it actually shines, it's in the variance of all the things that it can contain. We mentioned handwritten data and multilinguality. So let's do both at the same time. In this case, I handwritten a doctor note that I wrote myself. Like that says basically your meeting at like 3:30 p.m. on the 23rd of July is confirmed in French by Dr. Dupont. Mistral OCR does a perfect job at extracting the context, while more traditional ones like text extract cannot do anything because it's scanned. It's a picture, and like Tesseract cannot do anything. So this is already like a huge improvement that VLM have brought into the field of OCR. But you might be wondering, like, when should you use our Document AI API? I guess most of you, it will be very closely tied to RAG and search when I say it like that. Just a quick reminder for all of you, RAG is actually you ask a question, it is compared, like the embedding of your question is compared to knowledge that you have embedded into a vector store. which gives you back some chunks that may be relevant to the question that you asked, which gets appended into a prompt. The question also gets appended, and an LLM basically gives you back the answer. The huge problem in RAG is that the retrieved chunk need to be text. And this is where you will need actually to use an OCR pipeline, is when you want to index your document. And you might be wondering why only texts. In RAG, this is mainly for two big reasons. One is multimodal embedding, so what allow you to aggregate and like compare your query to your document which are in your vector store are text only. Multimodal embeddings are not yet performant enough for those kind of questions. And the second question that you may have is, like, if I provide my document, let's say to Mr. Large or ChatGPT or Gemini, it can answer some question over it. But there's actually a drawback, is that images actually take a lot of tokens. So if you look into the pixel architecture, it's actually an interleaved tokenization of text, image token, text, and image token. But the distribution, like actually the percentage of token that each of those modality take, is very skewed. So if you planning on making a lot of requests to the same document, you might also be better off by just having the text extraction of this model, of this document, rather than like the original document with all these modalities. So basically, the N word here is you should put better quality and more time into indexing phase of your RAG application. As a lot of application, it's garbage in, garbage out, meaning like if you want to have meaningful answer at the end of your pipeline, you should also like put meaningful information into your vector store. So how it should look like is you give your raw document to our API, you get back the markdown representation of your documents and annotation, which is a concept that we haven't gone through yet, but we'll do that right after. And those things that you get, you will chunk them and actually just embed them into your vector store. Actually, I kind of went over and brushed over some concepts. When you do put your documents through our Document AI API, as you've seen, you get a markdown representation with some images. And I've told you previously that you don't want any images. So what you can do, and what is also part of our API and why it's strong in those cases, is you can have annotations. On those images, you have two types of annotation: bounding boxes annotation, so annotation on those images extracted, and document annotations. What information do I want to extract from my document? Since it's VLM based, you have the power to actually interact with document and ask comprehension question that would need some thinking, basically. It's pretty easy to extract some information. You can provide a pydantic schema of the information that you want to extract, and those fields can be like given to the Mistral client in the form of the bounding box annotation field and the document annotation field. In this case, for instance, I have a document field as the document annotation, in which I ask a language, which is in a ISO format, a summary of the document, and a list of authors. And for the bounding boxes, whenever there's an image, I ask, is it a graph, is it text, is it table, or is it image? So again, the bounding boxes reference to the image that you extract, and the document annotation reference to the overall content of your document. Let's see that in a demo. I pre-computed some example that I find interesting. again in this playground that I created, we have Pixel 12b. This is the raw content out of our API with actually the Markdown presentation. You have the title, you have the images, which is here, which you can replace live. It's a Markdown representation, so you can render it. And you have like basically the whole content of the document with tables being in Markdown format, which you can visualize pretty easily. I asked for bounding boxes annotation to be images, and pretty much the same one I showed in the example, whether it should show me graph, text, tables, or images. So let's see how it fared. I didn't ask for any annotation on the document, but like the bounding boxes, we can see that on the first page, I have the Mistral AI logo, which is in 3D, with a gradient color transitioning from yellow to orange and to brown, which is correct. On second page, I have two scatter plots comparing the performance and cost number of parameters for various AI models, and so on. And again, this is an analysis that is correct. This is a little bit different for, like, this is a research paper. So basically, you already have examples of what, and textual example of what those figures actually show. But for different documents, it would be much more interesting. And the idea of that is whenever you are interacting with your client, you can choose to add this information back into your document. Basically, when you're doing search and you are embedding, since they are only comparing text with text, there's most likely a lot of information that you are missing, which are contained in tables, which you would be missing that are contained in charts or in images. If we should choose to extract it, the same way that I did it in the demo and in the code, and that we recombine it. So we can see that the difference in the answer, we have the exact same format on which we have the pages by index, the Markdown representation, but for each of the image, we now have an annotation, which corresponds to the schema that we pass in. So here, in this case, it's an image with a description of what this image actually is about. And so if you decide to input your document to a vector store, it can be interesting to add those captions of images into your original documents, or add back those information about graph, add back those information about pictures, and so on and so on. So this is, you are not losing any information from your document. Let's see that in action with other documents. Here I have, for instance, a financial document. It is a complex layout in the sense that it has some tables. It does have a lot of numbers that can be complex to process and to extract. Some like footnotes and so on, and at the end a chart. In this case, I still asked the basic annotation schema for the bounding boxes, the same one, just extract the chart and give me a description of it. But the difference here is that I asked my model to actually think over the whole document and give me a financial summary of the content. Meaning, like, I want you to extract the company name, I want you to extract the fiscal year, the income of the company, a summary, and optionally, like, what is the currency that this income statement is using. This is doing a good job. So we can see that the Markdown representation row is good. The rendered one is like very good too. And the information that have been extracted are absolutely correct. So the company name is Wikimedia, which we can find here. The fiscal year is 2008, which is correct. The income is 6 million, which you can find here. And a summary, which is here, and the currency used is USD, which you can find in many spots here, basically dollar change. So you can actually ask some information instruction over your document, more than just transcribe your image as text. You can ask the model to think around the model. A more impressive example, for instance, is this medical report. I know a lot of companies that are in the medical field would be very interested in that. This is one of the edge cases that model and OCR usually have, is we are not doing well at checkboxes recognition, for instance. This is a medical report which has like a lot of doctor notes, information about the patient on the first page, some medical notes, and then some bounding boxes, like a diagnosis and some bounding boxes. So I want to extract the bounding boxes in this case, and like what are the actual answers. As always, the OCR answer and the rendered OCR are looking good. But now on the document aspect, if we look at the pydantic schema that I've provided, I'm asking for a patient info with asking for its name, its age, its sex, its patient ID, its phone number, and a form answer, which is a list of checkboxes answer. And the checkbox answer is a type that I've done myself, which contain a question in the form of string and an answer in the form of Boolean. And if we look at how did the model extract, the quality is actually amazing. We can see that the name has been correctly extracted to Mr. Tan No, which is actually on the first page. The age is actually 55. The sex, which I asked, is indeed male because it has been inferenced from the Mr. present in the full name. The patient ID has been correctly parsed. The phone number has been defined as not provided, which is true. This was a tricky question to ask the model. At no point in the document is a phone number provided. So it was smart enough to inference and like to infer that a phone number should have a specific format, which none of those numbers correspond to. And finally, the form answer are a list of question and answer. So if we actually scroll down to the checkboxes, we can see that the first question, in your opinion, can the patient understand information relevant to a decision relating to his or her personal welfare? The answer is false. The second answer is also false. The third one is false too, which is true. And then the fourth one should be true. And like that's correct. And I checked them personally. All of them are correct, which is pretty impressive for the medical field. I do have another note. If your RAG pipeline is only based on text, you might want to actually index your document like so, where you have a reference to the image and only like what the image or the graph contains based on the bounding box output that you can compute into the client. All right. With that said, I will send you back, obviously, the notebook. You can find all the useful link here on the documentation, the blog post of Mr. OCR, and the cookbook. And now I think we can move on to the Q&A, if that's all right for all of you.
Okay, let's move on to the Q&A. Thank you, Geoffrey, for the awesome demo.
You're welcome.
We have a lot of questions to power through. Let me just bring them up. Cool. Okay. We still have plenty of time to power through some of these, but let's pick them. I believe they should be in chronological order. Okay. First one was from Pierre. I'll bring it up on screen.
Yeah.
So in the previous OCR version, there were some mistakes with dark mode OCR, reading white text on dark backgrounds. Has this been improved?
So if I'm not mistaken, this is still the original OCR model, which we did improve on the extraction side. But as always, it is an API, so it will receive like consistent updates. So you can look forward to those kind of updates. I haven't seen those kind of failure mode myself, but if it did happen on your model, on your documents, like the model will receive updates anyway.
Cool. Okay, let's jump on to the next one. We have a question from Alexandra about this session being available afterwards. Yes, there will. This whole recording will be available on demand after this live stream. So it should be on LinkedIn and on YouTube, on our YouTube channel. Next one was from Charles. Has this model got potential for accurate HCR? Geoffrey, any idea? Or we probably need some clarification.
Yeah, clarification on the
Yeah.
HCR sign
Okay.
from Charles.
Charles, maybe you can add a clarification. If we can get round to it at the end, we will. Over to a question from Bruno. Please add support to export B-boxes for text, not images.
Yeah, very good point. There's actually a workaround if you want to extract some information by going through the document annotation and not the bounding boxes annotation. Bounding boxes annotation are meant, like, from my perspective, to replace the content of the images that the model captioned, and like actually have a replacement text for those modalities. And if you want something else extracted, you should go through the document annotation rather than the bounding boxes. But that's possible, yeah.
Yeah, well, without the workaround, this is a known limitation, something that we will be working on improving on the next model iteration. But otherwise, yes, it's Geoffrey's suggestion. One from Lucy. So Lucy asked, do you need to code to use Mistral's OCR?
So this is a pipeline. So if you want to call the model, you can do it with code. But if I'm not wrong, this is also integrated in Le Chat when you provide document, right, Arthur?
Mm-hmm. Yep, correct. Okay. Do keep them coming. So
yeah, the next question is where the extracted image will be stored. So it's actually a base 64 answer of your image, so you can just get it back from the API. It's not like stored. It's up to you to decide what you do with the image that you get back from the API answer.
Okay, next one is from Ryan. The handwriting is way too neat for a doctor. So that was probably in the example showed earlier. True. What I actually should add, and this is quite important, there is of course a line in handwriting being discernible and also ineligible, and it should be noted that while the OCR model is able to understand well most handwriting and also in different languages, if it gets too complex, so to the extent where it's completely difficult to read, the model can struggle in some of these instances. So just worth noting that it's something that's worth pointing out with this particular example, as doctors' handwriting can be extremely tricky in some cases.
Yeah, that was just an example of handwritten data, and I took the doctor example as a placeholder, basically, like as an example.
All right, one from Louis. Does your OCR handle prompt injection risks hidden in PDFs? For example, invisible or malicious text?
This will be up to you to like detect what you are sending to the API. Basically, it presents the same risk as any model present on an API. No particular security from my knowledge. Yeah. What GPU are you using locally? So I'm running on a Mac, but for this specific demo, this is not really like relevant as it's using API. So this is using like the power actually from our inside GPU.
Okay, how are we doing for time? We've got another 10 minutes or so. So let's power through, try and get as many as we can. Arash asked, can it apply judgment and context to text extraction?
Yes, basically this is what the document annotation does. You can provide whatever pydantic schema that you want to apply judgment, like that would reflect the judgment that you want your model to do on the document, and you would be good to go. And there's also, there's a chat mode that I haven't demoed here, but you can ask question on the documents.
Maybe a familiar face, Joshua
Yeah,
Mayer.
a very familiar face. We met multiple times in Paris. He did the cookie models, which are very good open source text-to-speech models.
Joshua has asked, can the API output images from the original document as standalone files? And if not, how about bound inboxes?
Yeah, these are the base64, so you will need to extract that yourself. Basically, every processing that is after the API needs a little bit of coding, but I think we provide all the necessary tool to build like a very strong document understanding pipeline and actually inject it into your own code base.
Okay. Let's pick through some of these.
Yeah. Let's
pick this one. Amit asked, will it be useful for Excel or structured data?
So Excel would be a bit hard in the way that tables on Excel are pretty much infinite. So you can probably extract pretty well small tables this way by just taking a screen capture, like or an image of your tables, and it should do a good job. But if you have very big tables, then it should be hard to process.
Okay. Yavor asked, how does this compare to single page text image table extraction against Gemini 2.5 Flash Pro?
So maybe you may want to show the benchmark that we had in the previous slides that we didn't show, but that we had prepared.
Let me quickly pull it up.
Yeah, the comparison to PyTesseract is actually to compare the performance toward like older OCR techniques, but we also have like examples of benchmark comparing to more recent ones. And actually, for the size of the model, we are a very good match against like up to date models. The thing is, this model has been actually fine-tuned on this task, so obviously it's better at this specific task of extracting text than like general models, even multiple times its size.
Okay, let's take this one by Vignesh. Explain the role of data augmentation in training robust OCR models. Yeah, there's a few questions in there. Maybe we could just start with a high level.
Yes, and it's also cut, so I would need to find it in the original. So maybe let's skip it. I don't know.
Uh-huh.
I cannot find the original comment. Sorry.
From a LinkedIn user.
Yeah.
What about 19th century handwritten text in official documents? For example, genealogy purposes.
Yes. I think just like doctor notes, those would be tricky, or like at least trickier than the example I showed. But it still shows massive improvement compared to what you had before. So I wouldn't expect like an error-free like digitalization, but it would be much better compared to what you could have before Mr. OCR.
Okay. Quentin asked, is this OCR Playground going to be available soon for prototyping?
Yes, I haven't made it available yet. For you may have a keen eye and seen that it was actually on localhost, but yeah, I will deploy it and give the link.
Okay.
Maybe we can like put some question together. Like I see about fine tuning, about deployment. So maybe we can, rather than like bring up a question to the screen, we can just say, if you are interested in having like a custom deployment or a custom model for this, you can contact us, and we would be happy to work with your company and actually deploy it on premise for you, or like train it to a specific use case.
Awesome. Okay, I think we're just about on time for that. What we'll do, we'll scan some of these questions on the respective platforms. For the ones that weren't answered, we'll do our best to address them. I think there's also a couple of questions for when will bits and pieces be available soon, new releases or updates. We'll also try and address that. So that just about wraps it up for today. Want to say a big thank you to all of you from joining us on our first webinar stream from all over the world. Thank you so much for your questions and comments. Great to see you all and engage with you. And thank you, Geoffrey, for the awesome live demonstration. And I hope to see you again soon on another one. Take care. Have a great rest of the day or evening, wherever you are.
Take care. Thanks, everyone.